All right. Hello, everybody. Thank you so much for tuning in to the episode 24 of Global AI, the podcast. Today, we have got David Smith from Microsoft to discuss about one of the hottest topics in the market, and that's around Azure OpenAI Service. Before we get into that, a little bit of intro of myself. So I'm Arafat Tehseen. I am joining you with my co-host Somi from Sydney, Australia. We both are Microsoft MVPs for artificial intelligence, and we have got an awesome guest, David. So before we get into anything anybody else, we'll directly go to David. And David, would you like to give us a little bit of intro about yourself? And then I've got a question right ready for you.
All right. Well, first of all, thanks, Arafat and Sami. It's really great to be here. My name, as you said, is David Smith. I work in the cloud advocacy team at Microsoft, where I've been for about 7 years. I lead a team of specialists in artificial intelligence and machine learning that try and educate the world about how Microsoft can help folks in that area. I'm based in the USA, near the San Francisco Bay Area. But I originally grew up in Australia, so I'm very excited to be connected with you folks in Sydney today.
Awesome. Yeah, that accent gives us that Aussie sound as well. So this is really nice. So very basic question, and this has come to me, and I'm sure to others as well. A lot of times that when there is an OpenAI service already, what's the need of Azure OpenAI service, and how it is different to those which OpenAI offers?
Sure, yeah. Well, let's start with ChatGPT, shall we? Because like most people have heard of ChatGPT, you're probably familiar with it. It's a consumer service that OpenAI, the company, provides. Now, OpenAI is a completely independent company that has produced these large language models. And with ChatGPT, as a user, you can log into the service, you can type, ask questions, get responses, use it interactively. So I refer to that as a consumer service. Now, by contrast, the Azure OpenAI service provides all of the same large language models that are available from ChatGPT and other services from OpenAI. But it's there as a service for developers to integrate these chat systems, these text prompting systems, these large language models in general into other applications through an API. Now, OpenAI, the company, they provide APIs as well. But in the case of Azure OpenAI, these models are number one hosted within the Azure environment. And most importantly, what that means is when you use the APIs for these models through Azure, you're doing it subject to all of the protections and service level agreements that Azure provides. So your data isn't going to OpenAI, the company, it's staying within your Azure tenant. And in fact, Microsoft cannot even see the data that you provide to those services. It's protected by all the standard Azure data protections.
Makes sense. So it's like a security layer on top of that as well.
Exactly. And it's not just the security, it's the privacy, it's the compliances, and all the other benefits you get from hosting applications within Azure. Yeah.
Cool.
That's very interesting. I want to get into a little bit more details, but before that, there's another name going around, which is prompt engineering, which is very much related to AI and ML. So I just want to see if it's, maybe the question is it going to be a profession, or I haven't seen a job posting about prompt engineering, but I'm hearing the name a lot. And if I want to be a prompt engineer, what should I start learning?
Well, that's a really good question. Now, I haven't seen job descriptions like that or heard about them. I just haven't seen them myself, but I think it's likely to be a thing. But for the benefits of those that might not be aware of what a prompt is, first of all, let's explain a little bit about how these models like ChatGPT works. It's actually pretty simple at the end of the day. It's a black box, which takes an input, which is a bit of text that we call the prompt, and it generates an output, which is a completion of that text that sounds good. Now, I chose those words very carefully. Sounds good. It's stuff that sounds good in terms of it's in the same language. It's a sensible continuation of the text you provided in terms of syntax and grammar and so forth. But it's not necessarily factual. It could actually be creative writing. And sounds good is really defined in terms of the data that was used to create that black box, the data that was used to train that model to recognize patterns in the inputs to generate the outputs. Now, for models like ChatGPT, that input data that it's used to train on is essentially the entire internet. So we've got all of science, all of literature, all of Wikipedia, but also all of the chats and conversations and blogs and everything else that you find on the web is how it learns to create these outputs that in some sense sound good. So to your question, yeah, go ahead, Samir. Yeah.
Isn't it the same thing that bot does?
That what? I didn't catch that word.
The bot itself.
Which bot are you talking about?
Like creating that response.
Well, yeah, the model is creating the response from a prompt to generate an output. Now, what ChatGPT does is kind of layers on top of that whole process by providing as its input at each step the entire conversation. And that's how ChatGPT acts as a chat.
Yeah.
Because of that single input, it has the entire context of the conversation. So it knows previous bits of information that have been in that text in order to generate an output. But that's a really, really good point, because that essentially is a really good example of prompt engineering. In order to make a chatbot, we engineer the prompt so that invisibly to the user behind the scenes is not just being provided with your latest question. It's also got the entire context of the previous history to generate a more meaningful output. And that is a form of prompt engineering. But there's a lot of other tricks you can do with the prompt. Like, for example, if you had a chatbot for, say, a store, you might inject into that prompt, again, invisibly to the user, information about your products or your prices or your location. So that information is available to the chatbot, even if it wasn't included in its previous training data. Because if you're using one of these foundational models like ChatGPT or GPT-4, it may well not be included in there, especially if that information was created after the model was first trained.
Yeah,
it makes sense.
That makes sense.
So it's like completing and you mentioned about this completion as well. So it's like if I said that I'm going to a park, and then it may complete that for a walk or to run, because it has been trained on the internet, and it keeps that context of like, where should I use. It may not be using that. It may not be completing as like, I'm going to a park and do an experiment, because people don't usually do an experiment in the parks.
That's right. It's based on the examples it's seen before. It's probably seen lots of examples of people writing. I went to the park and went for a walk. I went to the park and did some exercise. Probably not. I went to the park and experimented in a lab. But another good point about this is that the response that it gives you, it might be any of those. It's essentially selected randomly, whereas the chance of the response being produced is proportional in a kind of way to the amount of times it's something like that has been seen in the training data.
Got it. I think that we definitely need a different episode for this, because there are so many questions coming up around prompt engineering, especially like what is few shot, one shot, and all that learning, and how do we increase it. But since we have got a limited time, so we'll definitely get into that in our next one, David, with you. Another question I've got with me is like, we have witnessed so many organizations and customers who really want to work with large language models, and we have seen so many libraries, or I would say frameworks coming up, such as LangChain and other stuff. And then organizations think that they really can deploy their large language models into their own premise, or into their, like, hold that workload into their own cloud subscription, I would say. Is it really feasible? And first of all, if it is feasible, and if it is not, then why not? And if it is, then how can we do that?
Yeah. So let's talk about these large language models, like the ones from OpenAI. So think about ChatGPT or GPT-3.5, which is the model behind ChatGPT. These models take months to train, and they work off, probably petabytes of data, and require often millions of dollars worth of GPU compute to actually train. And And in terms of actually running those models, you need a powerful computer to even run those models after they're trained. So this is kind of really in the realm, of the cloud providers. If you want to customize those models somehow to make them behave with knowledge or information outside of their initial training data, there's really only two options today. One is a process called fine tuning, which is essentially a process of modifying those foundational models with additional training data. But that in itself is a fairly expensive process. And then once you've done that, you've got to go through the process of hosting that model, and that has its own costs and downsides and so forth. It seems to be that the way the industry is going and kind of what actually works the best is, going back to your question, Sami, is prompt engineering. Is figuring out ways of providing the necessary contextual information in the prompt to generate the responses that suit your particular use case.
I think this is a very, very good point, because this brings me to another question, David. Then, like, fine, I get it, that fine tuning, and the other one I think is the RAG pattern, where we utilize the existing data, and then using prompt engineering, we take out our responses, or the desired responses. But another question comes to me, and that has come to me, like, at least from real clients, that they want to host something for their own enterprise. Like, they don't want to bring that whole bunch of data to because they are still, a couple of folks are still thinking that OpenAI is equal to Azure OpenAI. Hence, that public information and all that. But really, how do enterprises utilize the power of OpenAI with their own data, so that if they search for, like, hey, I want an expense sheet from my X department, what's that? So
So I think, first of all, that's the benefit of using Azure OpenAI Service. So you have these big models. It's not really feasible to host them on your own infrastructure for lots of different reasons, but they are available within the Azure tenants. So if you're putting an application around these Azure OpenAI services, all of your data is protected within your Azure tenant, as it is with any other cloud-based application. But you mentioned RAG, the RAG pattern, and that's kind of the architecture that people are using these days to provide what I call grounding for these models. So, for example, let's say you had a tech support system, and you have lots of technical articles or prior interactions with customers based on your specific proprietary products, which are either not available to the public, so couldn't have been included in the training data before, or perhaps new, so they couldn't have been included in the training data because it was produced after the model was frozen. The RAG pattern, which stands for Retrieval Augmented Generation, is basically a two-step process. Once somebody asks a question via the prompt through a user interface, you then go through a process of searching through your proprietary data, extracting out the pieces that are relevant to that particular prompt, which you can actually use LLMs to do, and then inserting that factual information directly into the context or the prompt, so that when the large language model like GPT-3.5 provides its response, it has that context to provide a factual response to the user that's relevant to the customer's proprietary data, without that proprietary data ever leaving the Azure infrastructure.
Yeah, it makes sense.
I have lots of questions in my brain, but I want to go through the list so we stay on track. As we know nowadays, everywhere we go, everybody's talking about the usage of ChatGPT or other tools like DALL-E, Midjourney. But in terms of like Azure, using Azure services within Azure OpenAI services within Azure, we see the approval process is pretty tight and maybe it takes time. Do you know why is that? Is there any other consideration that Azure does?
I think I missed a word. Which process did you mention there?
Azure approval process for OpenAI services.
Approval process. Okay, yeah. So for context there, to get access to Azure OpenAI service, number one, you need to have an Azure subscription. But specifically for Azure OpenAI Service, you need to complete a form, which basically declares what the use case is for how you're going to apply this model in practice. And that's basically centered around Microsoft's responsible AI principles.
I see.
These large language modules in general, this AI, these new AI systems are changing the world pretty rapidly.
Yeah.
And basically what Microsoft wants to do is make sure that all users of these large language models adhere to the principles that are listed in Microsoft's responsible AI principles, which are available on the web. But basically say you want to make sure that any applications of this technology is fair, is transparent, and fundamentally doesn't cause harm for individuals or for society. So it's a pretty simple process to go through that application process. It clears pretty quickly. But as long as your application is not something that is trying to do something bad in that sense, then you're available to use it within the Azure OpenAI service.
Can a private or individual start using it, or should it is only available for enterprise?
Yeah, individuals can absolutely use it. You can have an individual subscription. Again, go through the same application process. For example, if you're a hobbyist, you can just talk about, I want to build this application and test it out. And again, as long as that application adheres to the responsible AI principles, you can do that.
In terms of privacy, does it learn from my data, because I need to share the data so I can get trained, etc., etc.? And does it learn from my data and consume any other use cases, or it's within the context of my own use?
So there's two questions there, I think. The answer to them is both. First of all, just a reminder the answer is no for both, is what I meant to say there. But as a reminder for the users, the people that are listening to this podcast, these responsible AI models are black boxes. Sorry, these large language models are black boxes. Once they're trained on their training data, they're frozen and they'll never learn again. Now, I think the concern that you're alluding to there is new generations of these models come out over time. They are based on new data and new examples that are used to train those models. Microsoft does not use any of the prompts or outputs that people use or generate with Azure OpenAI Service in the training of any models. It's completely secure within the user's tenant. Yeah. The only exception to that, and again, this goes back to responsible AI principles, is that Microsoft does by default ensure that any of the prompts or outputs are, again, adhering to responsible AI principles, so that nobody's attempting to use prompts to try and cause the AI system to do bad things or to generate bad outputs. Microsoft provides that as a service to our enterprise customers, to make sure that all the users are complying with, their own principles. But if there's a need to not have the inputs and outputs go through that service, enterprises can opt out of that process.
Oh, okay.
Oh, okay. Yeah. This is really nice, because I didn't know about it in a way that Microsoft does allow you to opt it out from that process as well. So super cool, because this has been a discussion within the industry that, hey, don't provide any sensitive data to these services, otherwise they are going to tell that secret information of your organization to another one.
Yeah. And that's one of the primary use cases of using it within Azure OpenAI Service, is that all of your data.
Yeah, makes sense. Absolutely.
Yeah. That's really good, and it is very important.
It is important for enterprises, for sure.
Absolutely.
So coming to since we are talking about so many organizations and enterprises, so do you have some interesting use cases and which you have seen, David, which Microsoft has implemented? Of course, we don't want to name them or something, but if you can just talk about them.
Yeah, I can give a public one. This one is actually available on the Microsoft website customer section. And this example is really interesting because a lot of the conversation around these large language models is in the context of chatbots, interacting, answering questions, getting responses to it. But my background is in data science. So an application that I actually find really interesting of these large language models is data extraction from large unstructured databases. And again, going back, Somi, to your question about prompt engineering, you can do things like, if you have, let's say, a lot of, this wouldn't be the architecture. Let's say you had a lot of text files that were previous customer service transcripts from interactions. You could write a prompt that says something like extract from this file the customer name, the problem that they described, and the resolution that the tech support agent gave them. So just 3 very discrete pieces of information. And the prompts will do that really well. You will extract out information from a piece of text given essentially plain English instructions. You can even give the prompt instructions to provide the output in a structured sense, like put the output in a JSON array, which I could then use to import into a database system or something like that. But being able to then apply a data extraction prompt like that over a very large database is a really interesting and powerful way of extracting structured data out of these masses of unstructured textual data that we have already. So the CarMax example, CarMax is the company, and this is a company based in the United States that allows people to purchase used cars. Apparently, one of the primary pieces of information that people that are buying used cars look to is reviews from prior owners of those cars. And one of the things that CarMax does to help make the listings for the used cars more attractive, I suppose, is they had humans that would review all of the different reviews and then write kind of a summary of what people had been saying about these used cars. Well, now they can automate that process. They can write a prompt which will be applied to all of the previous reviews that have been applied to a particular make and model of a car, and then use that to generate a description of here's what people have said about this car, and then put that into their landing pages for each make and model of car. And apparently, according to CarMax, the large language model generated summaries generate more sales than the ones that were previously generated by the human adapters of this sort of unstructured data.
This is interesting. Really interesting, because you are absolutely right, David. I've also seen a couple of use cases around the chatbot or conversational experiences, but not extracting the unstructured data, bringing up to a different interface. So really good to see these use cases coming up, and that's of course going to exploit the I think the power of OpenAI or large language models.
Yeah, and I think the really interesting thing about these applications is that they're offline applications. So not only do you get to make use of all this unstructured data that you have around and haven't been able to get information out of, you don't have to worry about things like people entering the wrong prompts or prompt injection or anything like that, because you have complete control of that process because it's happening offline.
Cool.
That's very interesting. So if anyone wants to get into maybe the land of OpenAI or learn about Azure OpenAI services, what background that person needs to know? Do they need to be an ML engineers or data scientists, or anyone can start their journey?
Well, that's kind of the beauty of it. Like, if you want to get into interacting with these large language models and get a start in prompt engineering, and that's the best way to get experience in prompt engineering, is just to try it out. There's not a lot of set standard practices yet. We're still experimenting and learning about what works and what doesn't. But all you need is the ability to communicate in language. Doesn't even have to be in English. These large language models support many languages. So being able to have a fluency with language and being able to experiment, trying different variants of prompts and seeing what works or what works sometimes but not consistently, and what doesn't work, just that experimentational nature really helps there. And within the Azure OpenAI service, there's a nice playground interface. It is a user interface. It's not designed for end users. It's designed for people that are developing these systems. You can type and try different prompts and try different system messages, and it's got all sorts of tools to help you with that experimentation. Now, if you want to integrate these models into applications, at that point, you do need to be a programmer of some kind, but it's a pretty simple API. It's, for those of you that have used the OpenAI API, it's essentially the same API. Slight differences in way authentication is done, but beyond that, if you've used the OpenAI API, you'll be very comfortable with the Azure OpenAI API. These are very hard words to say.
Yeah,
Yeah.
it makes
The
that.
name is
So
pretty catchy, so I'm really start thinking about shifting career.
yeah, it's, I think so. It's developer. If you are a developer, then definitely, and if you are not, I think then just to add to this that um, our friends in Power Platform have done a great job of incorporating AI Builder with those Azure OpenAI
Mhm.
service as well. So if they are no code expert, if somebody is no code maker, then can they can also utilize the power of
Yeah.
Azure
That's a
OpenAI
really,
service.
really good point. Yeah.
Yeah, yeah. This brings me to the last question, David, and this is I've kept it to the last because we wanted to have a discussion about it. But yeah, definitely, as I said in the start as well, that a prompt engineering topic requires definitely a different episode. But we've seen that people have started generating content, and that content is neither true or it never existed. I've
Mhm.
never seen a person on a beach and also wearing an astronaut uh, uniform, or
Yeah.
things like that, or spacesuit. So and similarly, when I've seen a couple of I've asked myself as well that a travel destination with a lava and a snow together in Western Australia, and it was like giving up all those results to me. It tried first that there is no place that exists, and I said no, there is, and then it started spitting out all that information because
Mhm.
I think um, it really wanted to give out something. So
Yeah.
what is this, and how do we get rid of the scenarios or the situations like this?
Yeah. So 2 points. First of all, um, there's lots of different uses for these large language models or these image generation models, like DALI. You might want it to do something practical or factual, or generate information that is true. On the other hand, you might want to have it do creative writing or generate something novel or write a brand new poem or anything like that. So something that's more on the creative side of things. Now, the point is there is no switch in these models between factual responses and creative writing. As I said at the very beginning of our conversation, all these models do is generate output that sounds good or looks good in the case of the image models. And that is defined based on something that looks representative from its training data. But to your point, you gave a really interesting example there. A lot of the failures that people talk about with these models, about them giving wrong information or hallucinating. I really don't like that term because it suggests that these models have agency, but at the end of the day, it's just a completions generation engine. There's nothing magical about it, but it does generate stuff that sounds good. Now, if the model is ungrounded, and in the sense that it means it doesn't have any examples or information to draw from, either from its training data or from the prompt engineering process that has injected information ahead of that prompt. Sounds good in that case just means a sequence of words that kind of meets the syntactic requirements of English or the particular context that you've given it, like give me a story or a poem or whatever. But it would just essentially generate random words that fit that structure after that point. It's not trying to lie, it's not hallucinating, it's just generating a sequence of words that fit a pattern. Now, your example was really good in that, you asked it about a place in Western Australia that has snow, and factually there is not. And it sounds like it gave you the right answer, first of all. Factually, there is no place like that. But then you said, yes, there is. Now, what you inadvertently or advertently, I'm not quite sure, but what you did by doing that is you grounded the model with information. Yes, there is a place in Western Australia that has snow. And then it used that grounding to actually generate its next response, which is, as you saw, it
Makes
made
sense.
things up. But you essentially told it to do that.
Yeah, makes sense. No, this is a very very clear explanation
Yeah.
that we are also responsible of, like, what are we getting out of it if we are trying to put something which is wrong in grounding it.
Yeah.
I think then we should also expect that.
Yeah.
But this is a very dangerous discussion, and discussion as in, like, this is a very responsible effort and it should be from all the organizations and individuals. I think we are
Just
at
one
time. Yeah, sorry,
Can I
Sonia, go
ask
on.
one last question on that
Yeah,
example? David, you mentioned that it goes and maybe review the conversation that we have. So the example that, for example, Arafat mentioned, if I does it learn from what I say, even if it's not grounding? So if it produces an information and it's wrong, and if I say, okay, the broad information is this one or something, that does it go back to the conversation history and correct itself for the next image?
In a very specific sense. So for application, for consumer applications like ChatGPT or Bing Chat, then yes, when it creates its next response or its next completion, it does have the context of the prior chat. But that's really just a trick that's happening behind the scenes, is that the user interface is basically providing that information to it without telling you. You can see the impact of that is if you go back to ChatGPT the next day, or if you click the start a new conversation broom in Bing, it wipes out that prior history. And now if you ask it about that previous chat, it won't know anything about it.
I see. Yeah, that was my follow-up question. Okay, got it now. Okay, so it only keeps that session, the information that we
exactly.
have.
Yeah.
Thank you.
Makes sense. Fine, then I think, as I said, that we are on time. So thank you so much, David, for your time. And I am definitely sure that a lot of our listeners will get some new insights, which they may not know by now, because I learned a lot from this conversation as well. And I hope the same for Somi as well. So
100%.
as I said, it requires a separate discussion on prompt engineering, and we'll definitely have you, David, sometime later for that, and we'll deep dive into that.
Yeah, I'd be pleased to come back sometime for that, and it's been a lot of fun today. Thanks for having me.
Thank you very much. Thanks, everybody. So we'll see you in our next episode, and thank you for tuning in.
Thanks, David.